Hello students, welcome to my class. Today we are going to discuss few questions related to JEE Advanced examination. So let's start the question answer round. My first question is, look at, check the following reaction Ca2B6O11 plus Na2CO3 which gives you A plus B plus CaCO3, is it? And B plus CO2 which gives you A. Then the product A is, tell me what is the answer. First of all, we have to complete the reaction. This is colemanite when treated with Na2CO3. This is one of the most important method for the preparation of borax. It will gives you Na2, yes sir, B4O7, yes sir, and NaBO2, yes sir. Then this NaBO2, this B and this one is A. This is B, that is NaBO2. And when NaBO2 on treatment with CO2, then what will happen? Again it will give Na2B4O7 plus Na2CO3. Clear what I'm telling? It again gives Na2B4O7 and Na2CO3. So for this reaction, I'm not going to balance as simple. Put here 4 NaBO2, you will get Na2B4O7 and Na2CO3. So in this case, what will happen? First of all, colemanite when treatment with Na2CO3 which gives you Na2B4O7 anhydrous formation, and this is the complete formula of borax, Na2B4O7 into 10H2O. And next one is NaBO2. Again, how to check this NaBO2 when treatment with CO2? It again gives Na2B4O7 and Na2CO3. This is one of the best question for 2019 JEE Advanced examination, because such questions are asked also by using paragraph. So the product A in this case we say that is Na2B4O7. As I told you earlier, this is inorganic chemistry, and inorganic chemistry we have to focus on the reactions, and we have to build strong concept. Otherwise it's not possible to solve such kind of question. No special trick is there. You have to memorize, you have to build a solid concept. Otherwise you cannot solve such kind of question. The reaction happens, it happens. What is the mechanism? That is you can say, but the product never changes. Clear? Now let's move to the next question. What is the next question here? Check it out, friend. That is again the same thing, that is identify X and Y in the following reaction. What is X and Y? Okay, then BCl3 plus NH4Cl in treatment with C6H5Cl chlorobenzene, then what will happen? That is the catalyst. And BCl3 plus NH4Cl, remember that is boron halide, boron trihalide, boron trichloride when treatment with ammonium chloride in presence of chlorobenzene. It gives you B3N3H3Cl3. Yes sir, you are correct. Now why I am telling like this? Because if it is X, then this one is NaBH4. Reduction take place, and reduction, that is the addition of hydrogen, and here the removal of chlorine take place, not only the removal of oxygen. Clear to you? So the product is B3N3S6. And one more thing I have to mention here, B3N3S6 is nothing but a important compound which is known as inorganic benzene, because it has a similar structure like benzene. Clear? So in this case the product X is B3N3H3Cl3, and which on further reduction gives you the next product borazole, that is we can say This is known as inorganic benzene. So the product is D, B3N3S3Cl3 and Y is equal to B3N3S6. Clear? Now I'm going to rub this part and we'll discuss the next one. Let's move to the next question. What will happen in this question? Check it out. This is the question. In B4OH hall 4 2 minus, the number of boron atoms having octet of electron. Do you know this is the ion related to this one? This is the other form of representation of borax, Na2. Yes, sir. That is B4O5. Yes, sir. That is OH hall 4. Yes, sir. Into 8H2O. Yes, sir. Na2 B4O5 OH hall 4 into H2O. Now, how to draw the structure? In this case, if I need to draw the structure of B4O5 OH hall 4 2 minus. In this case, what will happen? Look at, that is B. Yes, sir. O, then B here, then O, then B here, then O. Clear to you? Then B here, then O, then B here, put here OH, put here OH, clear to you? Put also here OH and put also here OH. Clear? Now one more thing I have to mention here. This one is O and this one is O. Check it out. B4. 1, 2, 3, 4. Oxygen. 1, 2, 3, 4, 5. Okay, B4, 5, OH all 4. O, 1, 2, 3, 4. 2 minus, you can put minus here. You can put minus. Sometimes during my question answer round, I have put a minus sign and also put here NO2. That doesn't mean this structure wrong. That is the symbolization. It can also be represented like this. It can also be represented like this. Clear to you? It depends on you. Now look at the question. In B4O5 OH hall 4 2 minus, the number of boron atoms having an octet of electron. It's very simple. Tell me which boron atom has octet of electron. Look at in this case. 1, 2, 3, 4. In this case, 1, 2, 3, 4. 4 bond, that is 4 to the 8. But in this case only 3. 1, 2, 3. 3 to the 6. Now the question is the number of boron atoms having an octet. Octet means friend 8. So tell me what is the number of, how many number of boron atom? This one and this one and this one is not and this one is not. So 2 boron atom has octet of electron. Now what is the answer? Sir, it's very simple. The answer is 1. Am I right? Sir, you are wrong. As you told, there is 2 boron. So why are you giving the B option as a correct option? Sir, C is the correct option. I know you are more talented than me sometimes. I feel like this because what I feel, if a student is preparing for JEE Advanced examination, and definitely he or she really a good student. Clear, friend? So if you have any doubt related to any question, you can easily approach to me. If you have any doubt regarding to the solution, regarding to the answer of any question, then also you can approach to me. Now I'm going to rub this part and we'll discuss the next part of the question. Tell me what is the next part of the question. Friend, are you sleeping or are you listening to me? Don't sleep, listen to me what I'm telling. Look at the question number 4, that is Na2B4O7 into 10H2O. As I told you earlier in my last question, that is what is the correct representation of Na2B4O7? That is, it can be represented like this: Na2B4O5 OH hall 4 into 8H2O. By using this, we can draw the structure of borax. Clear? So what is the correct representation? Which one? This one is not a correct option. This one is not a correct, this one is not a correct, this one is the correct option, Na2B4OH whole 4 into 8H2O. So for this, B is the correct option. Clear, friend? Now I'm going to rub this part and let's move to the next part of the question. Amorphous boron is extracted from borax by following step. Okay, borax A plus H3BO3 gives heat B2O3 and B is boron. Okay, first of all we need to complete the reaction, is it? Now tell me how to complete the reaction. As I told you earlier, what is the formula of borax? Na2B4O7. Okay, now H3BO3, then definitely when it is treated with H2SO4, aqueous format, aqueous H2SO4, then it gives you H3BO3, yes, as a main product. And when H2BO3 is heated, yes, it gives you B2O3. Yes, when B2O3 is treated with stronger than boron, that is Mg, it gives you, that is B plus MgO. Yes sir, this is a complete reaction. So what is given here? Borax, that is borax is aqueous borax when treatment with A, that is this one is A, friend. A is aqueous H2SO4. okay, when treatment it gives a B2O3 is the main product. Yes, B2O3 is a main product. And if B2O3 is the main product, then on treatment with Mg we need to remove hydrogen because we are getting boron. So removal of, sorry, not hydrogen, removal of oxygen is known as reduction. So we need a strong agent than boron, that is if you use magnesium, then what will happen in this case? Magnesium will release oxygen from here and for magnesium oxide and gives boron. Clear? So this one is A and this one is B. So in this case the option is A is aqueous H2SO4 and B is Mg. So we people can say for question number 5, C is the correct option. Is it okay to you? Now let's move to the next question. Wait for a moment, what I am telling, listen carefully. Now the next question is the number of isomer possible for B3N3H4. Okay, this is the inorganic benzene B3N3S6. Okay, removal of hydrogen take place, removal of hydrogen and addition of halogen. Then it forms the formula B3N3H4X2. This is the formula. Now how to draw the possible isomer in this case? Now look at what I am telling. Check out the thing and wait for a moment. First of all, let me draw the structure of inorganic benzene. Put here N and N, put here B, then N here, then put here B, then N here. Okay sir. Now this one, now this one, and now this one. Clear to you? Now in your book this one is not written, it is written like this bond. So don't get confused, this is a coordinate linkage. Clear? Now what is N3? This is B3N3. Now H4X2. Put here X here, this was this, put here H, put here also H here, put here also H. Wait for a moment. Put here also X and put here H. This is the one form. And how to get the next form? If I convert this one, X will come here and H will come here, then there is a next formation. I am drawing the next structure. Look at this one is B, put here X. Okay sir. This one is N. Okay, this one is N. Wait for a moment. Put here N. Okay, now put here B, now put here N, now put here B, now put here N. Clear to you? Now that is X, put here H. Okay, this one is H. Now exchange, there is X, there is H, and there is X. This is now this one this one and this one. Clear to you? And put here also H. This is the next form, next isomer. Clear to you? Now the third isomer, put here X and also put here X, then H and H. The third, I'm moving here, friend. Look at the structure. Put here again B, that is N, that is N. Clear to you? This one is B, this one is N, this one is B, and this one is N. Okay, sir. Now put here this one and now this one. Okay, sir. Now this one. Now put here X here and this one is X. Put here H, put here H, put here H, and put here H. Okay, looks different from this structure. There is a position of halogen changes. This one is the third structure. Okay, is there any more possibility to draw the structure? What to do? Tell me. Yeah, definitely. If I put X here and one X here, then is the another structure will be possible. So I'm moving here. Check it out. The next structure will be, that is B, that is N, that is N. Okay, this one is B, this one is N, this one is B, and this one is N. Okay, sir. Wait for a moment. Put here this, put here this, and put here this. Now put here H, put here H, here put H, now H, now put here X, now put here X. There is many more possibility. I have substituted. I'm moving here, friend. Check it out. Look at what I'm telling. One position here. Okay. Now second shifted here position. Now third here and here. Okay. Now fourth here and here. All four position I have captured. I think in this case there is total 4 isomeric form. More isomeric form is possible or not? Check it out, friend. If you think that more possibility, no. Again I am repeating. HH, XH, okay, then XH, okay, 2 halogen substitution is the first isomer, and then if I put here X and then if I put here X, the next one is XX, okay, the second isomer, exchange of position, XH, the third isomer, and put here X and put here a fourth isomer. So total number of isomer in this case, after drawing the entire possible structure, we observe that 1, 2, 3 and 4. So total number of possible isomer in this case, sir, this is 4. So for question number 6, B is the correct option, and this is one of the most beautiful question for JEE Advanced examination 2019. Clear? Now I think you have drawn this figure, so I'm going to rub this part and we'll discuss the next one, the next question. So total number of possible structure, possible isomer in this case, that is 4 types. Now if I put here H3 and then X3, then the number of isomer will be changed around more than 4, around 6 isomers in this case is possible, friend. You can also draw, check it out whether more than 6 or less than 6, it's up to you. But what I feel, what I assume in this case, there is almost 6 isomeric form is possible. Clear? Now I'm going to rub this part and we'll discuss the next part of the question. Look at compound X on reduction with LiAlH4, okay, lithium aluminum hydride gives a hydride containing 21.72, okay, it gives a hydride, okay, hydrogen along with other product. The compound Y on react with air resulting boron trioxide, then definitely it can easily be calculated. If there is a boron trioxide, that is B2O3, that is definitely the hydride is boron hydride. What is the formula of boron hydride? BeS3. As we know, this is electron deficient compound. The product is here B2S6. So definitely by looking at the question, if anyone asks you what is the product here, sir, B2S6, and the product in this case we can say B is the option. Now what is the complete calculative part, and after calculation we will say that definitely B is the correct option. So check it out what I am telling. Look at According to the question, compound X on reduction with LiLH4 gives a hydride Y containing 21.72% hydrogen along with other product. Okay, that is Y plus O2. It gives B2O3. Definitely it gives B2O3, that is Y is B2S6. Yes sir. Now here is given 21.72. Now calculate the percentage of hydrogen in B2S6. Okay, that is total 6 into 1. What is the molecular mass of B2S6? Boron. The molecular mass of boron is atomic number is boron 5. 5 to 11, around 11 into 2, 10 point something, and plus 6 into 1, that is 22 plus 6, 28, around 28, multiply by 100. 6 upon 28 into 100. Clear to you? Then 6 1s are 6 4s are 24, 6 6 are, yeah, that is 100 upon 4.6. 100 upon 4.6, if I assume it as 5, near about it will give you 21%. Estimation 21%. Then definitely the B2S6, according to the question, the Y is B2S6 because in B2S6 there is only around 21% hydrogen. Clear to you? So now we can easily guess that is Y is B2S6. And what is X? That is, as I told you, BCl3, because on reduction with LiAlH4, reduction take place, that is the removal of here chlorine and addition of hydrogen, it gives you BS3. Clear to you? This is one of the famous LiCl and AlCl3. As we know, this one is not exist. This exists as a dimeric form, that is B2S6. So this is the complete detailed solution. This one is X and this one friend, this one is Y. Yes sir, Y I have calculated, it contain around 21% hydrogen. So definitely Y is boron, diboron. B2S6. It has a structure, tell me, ethane type structure. Sir, you are wrong. Are you kidding? This is a electron definition compound, banana bonding, or you can say bridge bonding structure. Clear? Now friend, I am going to rub this part and we'll discuss the next question. Wait for a moment. What I am telling, listen carefully. Question number 8. A colorless solution X gives a black precipitate. Okay, black precipitate, generally it may be a PBS or maybe HGS. Okay, on passing H2. So clear? X also give a white precipitate. Okay, with stannous chloride. Okay, which gradually change to gray. Gray color, that is. Tell me, sir, it's simple. The gray color, not PB, the gray color is HG. I have discussed it in salt analysis also. What may be the X? Completely, that is, the X is the compound of Hg, compound of mercury. So, compound of mercury, check it out, sir, only one option, that is HgCl2. Clear to you? On, that is the reaction X. Now what is the reaction? HgCl2 on passing H2 as gas, it gives you HGS, that is the black PPT. First part of the question. Clear to you? Now HGS, X also gives white precipitate. X also give white precipitate with stannous chloride, because which gradually change to gray, because it will form SnCl4 and the release of Hg take place. That is when treatment with SnCl2, SnCl4 plus Hg, and we people know this is gray in color. Remember this is gray in color. So by giving the detailed solution, I want to say that if you know the basic concept, then you can easily proceed, because sometimes in question there is a clue for the answer. Black precipitate, either generally it may be PBS or HGS. Okay, more possibilities are there, but in calculation here is PB, CD, HG and CU. CU is also black form precipitate, but CDS not black friend, CDS is a yellow precipitate. So we can assume here, but generally here is PB, and here after writing the next one, that is gray in color. Which one is gray? Not PB, not CU, and gray is HG. So that is the X is definitely the product of definitely the product of Hg, mercury. Now which one is the product of mercury? Sir, HgCl2. So X is definitely HgCl2. Now check out the relation here, HgCl2 plus H2H, which gives HGS, HGS and HgCl2 when treated with stannous chloride, that is SnCl2, it gives you SnCl4 plus Hg, gray in color. This is again one of the best question, and this question belongs to salt analysis also. Clear, friend? So be careful, it will definitely give you around 5 marks if you have a solid command on such kind of questions. Clear? Now I'm going to wrap this part and moving toward the next section. Look at what I am telling. Wait for a moment. Now the next part of the question number this is completely theory based. Under hydrolytic condition, the compound used for preparation of linear polymer and for chain termination. In polymerization, you also have noticed it. This is the compound cyclic, that is CS3 halt twice SiCl2. This is completely theory based. You have to remember this. And CS3 halt thrice SiCl. So for this question, B is the correct option. Now, wait for a moment. Let's move to the next part, last question. What is the last question? Check it out. This one is a passage type question. Read the passage carefully. What is given here? The heavier elements of group 13, group 14 and group 15. Okay, beside their group oxidation state, group 13 the common oxidation state is +3. Group 14 the common oxidation state is +5 and +4, and group 15 the common oxidation state is +5. But here is the changes. Group 13 has common oxidation +1 and +3. Here +4 general, +2 and +4. Here +3, +5 and sometimes that is -3, and the ranges from -3 to +5. Clear to you? Now another oxidation state which is 2 units lower than the group, as I told you, 2 units lower than +5 +3. Okay, the stability of the lower oxidation state increases down the group. Okay, why? This is due to the inert pair effect, as I've discussed during my lecture session. The display of the lower oxidation state is due to, as I told you, the display of the lower oxidation state is due to inert pair effect. That is, if I talk about group 13, that is from boron. If you move down the group, if I talk about group 14, carbon down the group, that is the electronic configuration NH2 and P1. Here the electronic configuration is NH2 and P2. But as we move down the group, the inertness of S electron to participate in the bond formation in the reaction increases. Due to this reason, only +1, only P electron release its electron. So down the group, +1 oxidation state is more stable in case of group 13, and for group 14, that is +2 oxidation state is more stable. For group 15, +3 oxidation state is more stable. Clear to you? So this effect is known as inert pair effect. Now read the question carefully. What is given here? Which of the halide does not exist? TiCl. Yes, it exists because lower down the group there comes thallium, so it can exhibit +1 oxidation state. But if I talk about boron and aluminium, they show +3 oxidation state. Yes sir, TiCl exists. PbCl2, Pb is +2 oxidation state. Upper side carbon but lower side Pb, down the group +2 oxidation state is more stable in case of group 14 element. So this also exists. PbBr4. As we know, if I talk about Pb, look at, is it visible to you? If I talk about Pb, +4 oxidation state is not possible. Here, if I check, that is Pb in PbBr4, Pb is in +4 oxidation state, which is not possible. So, B option is not a correct match, that is this type of halide does not, so PbBr4 does not exist. Clear to you? Now I am rubbing this part and let's move to the next part of the question. Now next question is, which of the following statement is incorrect? Boron So plus 3 as I told you, boron So plus 3 higher, gallium plus 3 oxidation state is more stable. Yes, definitely. Sn plus 2 oxidation state, as we know for Sn there is 2 oxidation plus 4 and plus 2 and plus 4, as we know for case of Sn plus 4 oxidation state is more stable, but for Pb plus 2 and plus 4 possible, but plus 2 oxidation state is possible. Clear to you? For Sn, what I am telling, plus 4 oxidation state is more stable than plus 2. So this statement is incorrect. In Sn plus 2 oxidation, no, this is wrong. So for this, C is the incorrect statement. So C is the correct option. Clear? Now let's move to the next question. The strongest reducing agent. Look at what is the strongest reducing agent. What is reducing agent? Then definitely it increases its oxidation state. If I talk about PbCl2 plus 2 oxidation state, so it will not convert to plus 4 because plus 2 oxidation state is more stable than plus 4 in case of Pb. TlCl, as we know, Tl has oxidation state plus 1 and plus 1 oxidation state is more stable than plus 3. So no reduction take no oxidation take place, that is it will not act as a reducing agent. But if I talk about germanium and Sn, it has plus 2, it has plus 2 oxidation state, and we know in SnCl2 plus 2 oxidation state is less stable than plus 4. Similarly, GeCl2 plus 4 oxidation state is more stable than plus 2. So in this case, they will act as a they will act as a reducing agent because they will increase its oxidation state and move towards the higher stable oxidation state. Clear to you? So in this case, the option A and B is the correct option. Clear to you? Now let's move to the next part of the question. Check it out what I am telling. Question number 4. The strongest oxidizing agent. What is oxidizing agent? That it will decrease in oxidation state. Now if I talk about SnO2 here is plus 4 oxidation state, it will not release because if it decreases, plus 2 oxidation state is less stable than plus 4 in case of Sn. If I talk about Pb, it is in plus 4 oxidation state and it will move towards the most possible most stable oxidation state, which is plus 2. Here the decrement is if there is a decrement in oxidation state, then we people can say that is it will act as an oxidizing agent. This will here look at plus 4 and plus 4. In all the three cases, plus 4 oxidation state is more stable. So no need to no need to decrease its oxidation state. So if no decrement in oxidation state, then they will not act as a oxidizing agent. So in this case, plus 4, it has a tendency to move toward the more stable oxidation state, that is plus 2, which is less than plus 4. So it will act as a oxidizing agent. So for question number 4, D is the correct option. Now inert paired effect is not shown by, we know boron do not show inert pair effect. After boron there comes aluminium till Tl, then in carbon also. Now boron. Now which of the following compound do not undergo disproportionation reaction? Disproportionation, that is variable oxidation state, as we know, that is TlCl, and TlCl3 does not undergo disproportionation reaction. Here is the plus 1 oxidation state and here is plus 3 oxidation state. Clear to you? I think you can solve such kind of questions very easily if you have a strong command on theory. So friend, I think we have completed this topic, and again review the question. Now what is the answer of the first question? Tell me. That is this one is a C option. For B, what is the option? So this one is the D option, B3N3S3Cl3 and B3N3S6. What is the option for question number 3? Sir, this is 2. What is the option here? That is correct. B option, Na2B4O5 OH all 4 into 8H2O. What is the correct option for question number 5? Sir, H2SO4 and Mg. Yes, sir. The number of isomer 4. I have drawn all the possible isomeric form. Now for question number 7, as I discussed, B2S6. Why is B2S6 an axis? BCl3. Yes, sir. For question number 8, colorless solution, black precipitate. So this is HgCl2. Now under hydrolysis condition, that is the B option, and for this tell me Pb, BrO4, third option. Then here is A and B option, here is D option, here is B and boron, B option, not B, that is D option. Here is A and D option, TlCl3 and TlCl. Clear, friend? So this is the last question of today's lecture. We will meet you again. Thank you so much.